Hello, I'm Hyuk-Jung Kwon, the author of this paper named From SAM to CAM. It is an honor to introduce our research in CVPR. Most of the modern semantic segmentation methods are based on fully supervised learning. However, the Pixar-1's dense GTs are usually expensive to obtain. To relieve this annotation burden, weakly supervised semantic segmentation uses weak labels such as image-level class tags. In weakly supervised semantic segmentation, an image-level classification model is trained using the class tags. Then, class activation maps of the classifier are extracted to identify the pixels belonging to each class. Finally, the CAMs are post-processed into a segmentation map, which can serve as a pseudo-GT for training the segmentation model. Meanwhile, the segment anything model has made its debut. The SAM is a foundational model for promptable segmentation using the input prompts that indicate where to segment from an image. Although SAM has remarkable segmentation capability, it does not include explicit semantic understanding. Within this context, the focus in the weakly supervised semantic segmentation has shifted to how to exploit SAM effectively. The early works mainly present SAM-based post-processing. However, we find that these approaches are vulnerable to the noise of CAMs as shown in the right figure. Such errors hinder the learning of semantic segmentation model. This means that the devil is still in the CAMs. Therefore, we propose to directly transfer the knowledge of SAM during the training of the classifier. Accordingly, we named our method as From SAM to CAMs. The proposed SAM to CAM comprises two components. The first one, SAM segment contrasting, aims to transfer the power of SAM segment everything option. This distillation is performed in a feature level via prototype-based contrastive learning. Specifically, we build segment-wise prototypes by aggregating the features corresponding to each segment. Then, a feature belonging to a certain segment, depicted as pink circle, is optimized to be close to the prototype of the segment, represented as red star. On the same time, the pink circle is trained to be distant from the prototypes of the other segments, such as green or blue stars. Moreover, we also introduce CAM-based prompting module to fully utilize the promptable segmentation capability of SAM. In CPM, we mainly focus on acquiring prompts that represent the localization achieved by CAMs. We find that using multiple local picks can be an effective option, comparing with using boxes or global maximum. Using the local picks as point prompts, we individually perform promptable segmentation using SAM and aggregate the resulting masks into one segmentation map. This map is served as self-supervision for guiding the CAMs themselves. During this aggregation, we also devise special confidence-based strategy considering both SAM stability and CAM score. We conduct ablation studies for component analysis. The first table shows that both SSC and CPM greatly improve the quality of CAMs. Also, we provide visualizations of the features learned with and without SSC, highlighting its effectiveness for learning segmentation. Finally, the second table demonstrates that the aggregation techniques in CPM meaningfully enhance the performance. We also compare the proposed SAM to CAM method with others on Pascal and COCO benchmarks. S2C shows much better performance than other methods at every stage on all datasets. For more fair comparison, we also compare S2C with the weakly supervised semantic segmentation methods enhanced by SAM-based post-processing. S2C still outperforms all of them, underscoring the benefit of directly transferring the knowledge of SAM to the CAMs. Finally, we provide a qualitative comparison with the baseline. As shown in the left, the proposed S2C achieves the CAMs with precise boundaries covering the entire object. These high-quality CAMs lead to outstanding segmentation results. In summary, we explored what is an effective way to leverage SAM for weakly supervised semantic segmentation. Our answer to this question is From SAM to CAM, which directly transfers the segmentation capability of SAM to CAMs during the classifier's training. We believe that our approach can inspire many other vision fields, especially from the perspective of fully unlocking the potential of the foundational model. Thank you for your listening.